Hi again, this is Jags. I'm the CTO at SnappyData. So if you watch the previous screencast, by now you have a good sense for how SnappyData is positioned as a cloud virtual warehouse and how it provides high performance analytics caching over any modern data source. Okay, now it's time for me to get into a demo. I essentially break it up into two parts. Part one, which is what I'll cover here, we'll look at essentially interactive analytics using notebooks and BI, see how easy it is and how fast it is compared to alternatives. And part two, which is a separate screencast, we'll look at real-time analytics. Essentially, we will look at capturing events inside the operational database. In this case, it will be MongoDB. And we'll route those events to SnappyData through a streaming pipeline. So essentially, the idea is that, hey, can I essentially get my insight if I'm using a BI tool or any other tool? My insight and my analytics is always on the freshest data. All right, so what do I cover in part one? So here it is. So the first thing is that we will show you, I'll show you the cluster and services running on Kubernetes. I mean, Kubernetes is our answer for how we essentially achieve multi-cloud. Everything is done using a couple of Kubernetes operators. I'm not going to get into Kubernetes, but I will essentially show you the commands I use, and we look at the Kubernetes dashboard. Then we will get into a notebook environment where we will immediately connect to data sources, where we'll show you how easy it is to infer schemas. We look at transformations. We literally, through a sequence of clicks, we will essentially load our data into our cloud cache, in this case SnappyData. Then I use Zeppelin to explore data using ad hoc SQL. We'll compare that to Spark performance using Parquet as a format, which is the fastest way to run Spark analytics. Then we'll look at, say, hey, given that SnappyData exposes everything also as data frames, how easy it is to use Spark's libraries to featureize and generate machine learning models. And then we'll come back and look at this very interesting topic, which I covered in my previous screencast. Essentially the use of stratified samples. So let's say the volume is very, very large and I cannot afford the resources, in this case memory. The idea would be to generate one or more stratified samples which are deeply integrated into our query processor, and how the stratified samples helps you to not only take large data sets and condense it into something very, very small. At the same time, you can essentially get analytical speed answers for the questions you could ask. And finally, we will look into a small illustration of using a BI tool to visualize our analytics. In this case, we will use Spotfire. All right, so here's the demo architecture. Everything is running on Kubernetes. First thing is that we use a data set. In this case, I'm using the airline on-time performance data that's published by the FAA. We have about, I believe, 7 years worth of data amounting to about 210 million on-time performance records for all airlines and all flights. So that data has been loaded into S3 in Parquet format. So we essentially point to that data, we infer the schema, register it as virtual tables in Snappy, and of course cache it in Snappy. Then we also get some additional data from MongoDB. In this case, we essentially get airline reference data from MongoDB. Then, as I mentioned before, we will run one or more notebooks to do simple analytics, essentially analytical queries on this data set. And finally, we will show you the use of Spotfire. All right. So with that, let us look at this is the Kubernetes Shell. So I've already launched a Kubernetes cluster on the Google Cloud Platform, the GKE. Of course, we also support other Kubernetes environments. Specifically, for instance, we support the Pivotal Container Service. And the benefit of using something like Pivotal is that you could essentially run Kubernetes on-prem using VMware virtual machines. And you get essentially you're running our operators in Kubernetes, and you can essentially take that same operator, switch over to Google Cloud and run it, and you'll get the exact same consistent a consistent feel for how your applications, in this case SnappyData and the entire analytics framework we are running, will be very consistent across all these sort of cloud environments. That's the idea. So how did I launch my clusters, my Spark components as well as my SnappyData components? we essentially use a Helm-based operator. Just through a single command, we have all sorts of sensible defaults, and you can override some of the defaults. It's very simple, so you don't have to really know a lot of the details around Kubernetes objects and resources. So the Helm LS gives me the real components that I've deployed into Kubernetes. As you can see, I have deployed a Cassandra cluster, a MongoDB cluster, and a SnappyData cluster. So let's look at the dashboard real quickly. So here is the Kubernetes dashboard. And what you can see here is that if I click on the clusters, I have a single cluster running. It's a very small cluster. I'm only running a cluster of size 4. Each node has about 4 CPUs for a total of 16 CPUs. And within that small cluster, I'm running and exposing all these services. I have Cassandra, Mongo, I have the SnappyData cluster, and several endpoints of SnappyData exposed. And finally, I have Zeppelin, which is our notebook server that I've exposed. I've also exposed Jupyter in case you want to essentially run Python workloads. The workloads here is nothing but the set of containers. I mean, without really getting into Kubernetes details, these are the pods that are running. A pod is nothing but an encapsulation on top of a Docker container. So for instance, if you look at the SnappyData server cluster, which is really nothing but the SnappyData data servers, I have 3 of those guys running. And of course, at any given point in time, you can, if you want, scale and rebalance the data across more nodes if you want to, right? So now let's look at the SnappyData dashboard. Here's the SnappyData dashboard, and it shows you that we have 3 data servers and a locator and lead node that's running. And I've also connected to our Zeppelin server environment. So here is the Zeppelin server environment. Let's first look at setting up our data sources. In this case, like I pointed out, the first thing is that I want to make sure I can connect to my Mongo server and really get the data from Mongo and cache it in. So it's a fairly straightforward self-service kind of notebook here. The first step is you register a data set, give it a name. I'm pointing to the MongoDB database. Here's the URI, and I'm specifically pointing to a specific collection. And the sample size really allows us to say, hey, if I run this, go and look at 1,000 random samples inside your MongoDB database, and then infer the schema automatically. So let's just give it a go. So as you can see, it connected to Mongo. And it resulted in creation of an external table in SnappyData called airline ref, and it's printed out this nested schema, which is what MongoDB has inside this collection. Of course, you can take a look at that sample data now, given that it's a table, and you can see that. Of course, you can do arbitrary transformations, and then finally, let's take that external table and cache that data inside a SnappyData row table. In this case, this is really a small table. It's got 1595 records. So we got our first table registered, essentially pointing to MongoDB. Let's go back. The next thing I want to do is to make sure I can essentially get access to the larger data set, which is sitting on S3, right? So again, you can, we support S3, HDFS, GCS, and a variety of file formats by which you can essentially upload your data into Snappy or register. So the process is exactly the same. You define a data set, you select the data source, you select the format in which the data exists. Then, if depending on the source and the format we've selected, that will automatically result in you we're showing you additional options. In this case, if I'm connecting to S3, obviously I need my S3 credentials and the S3 bucket from which I'm going to fetch it. I'm not going to run this here because it does take a while to load 210 million records from S3. So already loaded the data. This table has been again registered. Like I said before, with Mongo, we infer the schema and we register into our catalog as an external table. And likewise, I've essentially cached the data into a column table in SnappyData. One interesting thing I want to point out is, of course, you might say, hey, my tables that are there in the source versus what I want to see in my catalog might be different. In other words, you might want to enrich, you might want to pivot, you might want to generate cubes, you might want to add additional columns. So here's a very simple example just using this Spark API, how you can do that, right? All that is relevant here is you can essentially access any SnappyData table, an external table or a cache table, as a data frame in Snappy. Here it's called df. Of course, I'm using Scala, so the types are inferred here. And I can use the Spark API. So in this case, I'm adding an additional column to this data frame called ID, and I'm essentially using a built-in function that gives me monotonically increasing number. And then, of course, I can turn around and simply save that data frame as a table. Okay, so I'm not doing it right now, but so you get the idea. So if you look at now our dashboard, you'll see those two tables. So you see that the cached tables are available inside Snappy, and the catalog has these external tables that are pointing directly either to S3 or MongoDB registered here. And as you can see, the airline cache table has got 210 million records and consumes about 12 gigabytes of memory. Of course, our cluster is really small. All right, so let's go back and see if we can run some simple analytics on this data set. So let's go through a little exploratory example to run some analytical queries. So as you can see here, what I have is all the panes or the paragraphs that you see on the left are really running directly, are pointing to directly the Spark data source, in this case the Spark Parquet files. And on the right hand side, I'm running exact same queries pointing now to the cached tables. So no difference, the schema is exactly the same. One comes out of memory, one is essentially directly going against the source. So if you look at the first query, where I'm saying, hey, let's find out which airlines have had the most flights. So I'm essentially doing a count query, and I'm joining the airline with the airline reference table, and I'm grouping by essentially the airline name, and I'm picking the top 8 of those airlines. I'm not going to run this thing because, as you can see here, it took over a minute. So if you run the exact same query using Snappy, that should take less than a second, right? So it took about a second. We can go in here into our dashboard, and we should be able to see that this is the query I ran, and it took about 0.9 seconds to run that query. So of course, you can run additional queries. So the point being that if you are using essentially SnappyData versus Spark, you should see anywhere from 10x, 15x, in some cases even literally 100x improvement in your performance, in your speed. So you make a decision to say like, hey, which classes of data is most frequently essentially accessed from either my BI tool or is relevant for my applications, and you can decide to cache it and leave the rest as external tables. Okay. All right, so that's the access. We demonstrated a very simple sort of exploratory notebook. Now let's look at what if I wanted to essentially land up doing machine learning models. So I'm not going to go through the details here. Let's just skim through it. Here's a notebook that is essentially saying, hey, can I essentially build out a model to predict arrival delays for my airlines based on the data set that I already have, right? So I mean, here are some paragraphs where these are just nothing but Spark API and code. The beautiful thing is that Spark is fused into SnappyData, which means you can create a notebook and use any of the Spark APIs, machine learning, graph APIs, of course, MapReduce APIs, all the rich transformation APIs and all that sort of stuff. So any table is also accessible as a data frame, as I said. So here is a thing that says, hey, give me the statistics of the various columns. I can look at correlations between departure delay and arrival delay. So essentially, I'm exploring, understanding my data sets, and then finally I can turn around and featureize. So in this case, to featureize, we explicitly first create a sample of my data set. And then I use a variety of techniques to featureize, and we essentially land up using a decision tree as our algorithm to really predict sort of arrival delays. Okay, so that's a little notebook on using machine learning. I just want to touch on this additional thing which we talked about, which is approximate query processing, or the use of sampling technology. Like I said before, if your data set tends to be very large, let's say in this case, our data set is relatively small. It's got 210 million records. What happens if the data set was billions and billions of records? And you really can't afford that memory. You don't want to pay that price of memory or the compute resources for a virtual database, virtual warehouse in this case. So what you can do is you can simply create sample tables. So think about sample tables as if they're like indexes on the data set that might be sitting at the source. So in this case, I'm creating, it's a simple set of extensions we have on top of SQL. Of course, we have a data frame API also. So you create a sample table. In this case, I'm essentially stratifying it on these three columns, and I'm saying, give me a sample that's just 1% of the full data set. And we supply access to the full data set simply using a subquery in this case, where I'm saying, hey, select these columns from airline, and as you noted probably before, airline is simply an external table pointing to a Parquet data source. And lo and behold, as you can see here, if I run start running my queries, what you'd see is that the query looks exactly like the query on the left, which is going after the full data set or the exact data set. The only difference on the right is that we have this with error clause. That is a signal to our engine to say, hey, if you have the relevant samples available, figure out which sample you can use. But the key restriction here that the user is placing is that he's saying, give me an answer back from the sample as long as the answer is at least 90% correct. So in other words, this with error of 0.1 says I can tolerate a 10% error. Of course, in this case, this query is giving you literally a 100% correct answer, essentially saying that, hey, the row count is 210 million, even though the real count inside the sample is just 2 million records. So it's a beautiful way to, or a very smart way to really build out high performance analytical applications, especially the ones where you are visualizing your answers, your aggregations. Because as you can see here, even though the answer may not be 100% correct, visually you can never tell the difference. I mean, if you're looking for a pattern, this is a great way to essentially use synopsis. So here is another analytical query which we ran before, where I'm essentially finding out which are the airlines that have the most flights, right? Likewise, you'll see many queries I'm running where here it's taking 20 seconds instead of 1 second with the sample, all right. So finally then, let me switch to saying, hey, I showed you the use of notebooks for exploratory analytics. We looked at how easy it was to set up access to my data sets that are external. Finally, let's look at whether I can get visualization using a BI tool. So in this case, I'm using Tibco Spotfire. You could use Spotfire, you could use Click, you could use Tableau. Any visualization tool that can speak JDBC or ODBC should absolutely work just fine. So I'm running Tibco Spotfire and using a Microsoft remote desktop. Spotfire is actually also running. In fact, right now Spotfire is running on the AWS cloud. So I'm using the visual tool is called Spotfire Analyst, which is really what you use to visually sort of analyze what you want. So in this case, as you can see, I'm already connected to SnappyData and I have the airline cache table accessible now, which is the data set I'm using for analysis. And Spotfire automatically looks at all the columns and figures out which columns make up categories and which columns make up measures. And all I do is drag and drop to do my analytics. So let's actually take unique carrier. Let's say I want to do the same thing, which is I'm trying to find out the average delays for each airline. So all I do is drop one on this pane, then I pick up so as you can see, the moment you drop a column in here, it automatically runs a query where it's found out all the unique values for that column. So in this case, these are all the airline codes. So let's take arrival delay, plop it into this column here. We don't want a sum, we want the average arrival delay. So we switch over to average and voila. I mean, it's immediately running a query on the 210 million records and plotted the answers here. So of course we can go back and see if what Spotfire ran. In this case, as you can see, it ran a range of queries. This is the last query we ran, which is a group query, and ran in 0.5 seconds, right? So maybe you want to sort of say, hey, I want not just by unique carrier, but I want to see the results even by year. So now I'm grouping also by year. Again, it's a different query that's running, obviously difficult to interpret with so many answers are coming back. So maybe what I want to do is I want to add a filter, and I can pick, let's say, United Airlines. And the moment you pick any of these things, again, it's running a query in the background, giving you the answers back. So there you go. I mean, so we covered what I wanted to show you. The fact that I can load from S3, I can work with Mongo. This is a small cluster running on Kubernetes. So you can essentially scale the cluster at any given point in time. If there are any failures, Kubernetes will automatically handle failures. I'm running Zeppelin, which is auto-connected to the SnappyData cluster. I didn't show you Jupyter, but you also have Jupyter as an option in case you want to run Python and work with the same tables. Okay, so there you go. We will soon have the next screencast done. Thank you.